Hello everyone and welcome to another Python video. In this one, we're taking up the factorial question. If you don't know what a factorial is, it's the exclamation mark operator in math. So for example, if I were to do 5 factorial, you do 5 times 4 times 3 times 2 times 1, which gives you 120. All right. So basically, if you have a number where like an n, if you do n factorial, you're going to take n and multiply that by n minus 1, then n minus 2, all the way down until you get to 1 and you multiply 1. Okay. So that's what we're trying to mimic. It's not the most hardest problem ever. So I wrote 3 different solutions, one using a while loop, and I wrote 2 using a for loop. Okay. All right, so we're going to break down the while loop first, and I'm just going to show you how that goes, but let's read over the solution. What I've done was I did 2 variable initialization, total product, and the multiplier. And my goal is I'm going to grow this value, and I'm going to be multiplying values to this variable called total product. I'm going to multiply 1, I'm going to multiply 2, I'm going to multiply 3, multiply 4, until we get to multiply our user input number of num. This multiplier, on the other hand, is going to be increasing by 1 at every iteration of our while loop in this case, so that we can multiply total product by multiplier, right? And whatever the new number we get, we're going to multiply by the new multiplier number we get, all right? So right now, we're going to say that as long as our multiplier is either less than or equal to the number that we've been given as an input. All right, so let's say if num was 5 and multiplier was 1, it would make this while loop condition true. Therefore, we get to execute the code inside our while loop. Okay, so we're going to say our total product is equal to whatever it was before multiplied by the multiplier, which is currently 1. So it just does 1 times 1. Okay, so product is still 1. But after that line, we're going to go multiplier is equal to multiplier plus 1. This value has turned into 2. Now, 2 is still less than equal to our hypothetical num of 5 in this case, so we get to still execute this code. Total product was 1, so we're going to go 1 times 2 now, taking the newly updated value of the multiplier, and we're going to multiply that to total product. Therefore, total product gets updated 2, and then multiplier increases by 1, so multiplier is at 3. 3 is still less or equal to num, so we get to execute our while loop again. Total product was 2. We're going to take whatever was prior, 2, and multiply by 3, which was the previously generated multiply number. So we're going to take 2 times 3, and total product has increased to 6. And we continuously do this over and over again as long as this condition remains true. When that condition remains false, we get to execute this line of code here where we can output factorial of num is total product. Okay, so let's break some programming parts down. We're doing a while loop. A while loop requires some sort of a Boolean expression, a condition, which you wrote during the if statement and when you learned about conditionals. Okay, we must indent. Right, we must use 4 spaces and indent to say that we're starting a while loop code block. We're writing all the code that belongs to this while loop, and as long as they're in this indentation area here, the while loop's going to execute the code as long as this condition is true. Okay. Now we can totally write total product is equal to total product times multiplier, but a faster way would be writing total product total underscore product by multiplier like so, and that would be the faster way. Much in the same way, we can say that multiplier is equal to multiplier plus 1, but a much faster way to write that in Python would be multiplier plus equal 1. These are called assignment operators, where this allows us to do multiply and assign, and this allows us to add and assign. Okay, so let's see the final product or output of this one. All right, so what I'm going to do is just execute my code. Currently, I'm not in my video solutions folder, so I need to say that I'm going to go into this folder and execute this Python code. So to run that, and let's say I did 5, we will get 120. And since I wrote 2 solutions, I'm actually going to get that output 2 more times, okay? And the funny thing about factorial is that if you just double our n, our result of our factorial is going to comically increase dramatically. So that's another behavior of Factorial. Okay. So this is how the while loop work. And what I want to do is really just copy this, and maybe I can show you the breakdown of how this is working when we put it into the Python visualizer. So I'm using the pythontutor.com, and we're going to be visualizing this code. So right now I have this code, and we're going to visualize execution, right? It's going to ask me for enter a value of n. Let's try a value of 4. Okay. Right. It's going to take 17 full steps for us to calculate the factorial of 4 with this solution. So we took our num, we're currently at this place, line number 5, and we're going to create a variable of total underscore product. And we have a multiplier, a variable created as well. And these are our starting values for our variable. Num is 4, total product is 1, multiplier is 1. That means our condition is true. 1 is less than or equal to 4. We get to execute this condition. And if you click on a line, it's going to tell you when this occurs, when this check occurs in our Python code. Okay. So we're going to continue on line 11. We're going to update total product. Okay. And it's going to be just 1 times the multiplier, so nothing's going to change. But on line 14, as we execute, oh, it skipped all that. I'm just going to uncheck that. If we go to line 14, we're going to see that after this line is executed, our multiplier has changed to 2. And now we are rechecking this condition now. Once our while loop is over, we go back up to our while loop and we recheck our condition. So 2 is still less than or equal to 4, so we get to continuously go on. And notice our total product has changed, and after this line, our multiplier changed. And our condition is still true. So we get to execute this while loop code block again, increase our total product, increase our multiplier. We're going to have our while loop looping for the last time, because this is going to be the last time this value is less than or equal to num. So we get to increase total product by multiplying total product by the multiplier, which is going to be 6 times 4, gives us 24 for the total product, and multiplier has now become 5. We go for the final time to our while loop, and we check this condition. However, 5 is greater than num. It doesn't make this condition true, so it skips our code block and goes to our print statement, and we execute that code, and we get an output of factorial of 4 is 24. So that was our visualization of the while loop solution. Now let's look at our for loop solution. Okay, our solution 2, right, is it's a solution that goes from inclusive of n all the way to 0, but not including 0. So to mimic what actually happens in a factorial equation like so, I decided to use a for loop like here, and this is how it works. All right, we're going to maintain our variable num here, and then we're going to create a new variable called answer2, and I'm going to initialize it to 1, much like how I initialize total product to 1 here as well. Okay, and I'm just using an iterating variable called I. That is called I is the iterating variable. It will represent each value in our sequence. And let me just bring that over. Okay, so when you create a for loop, you have to always create an iterating variable within for and in. And that's going to help us represent each value in our sequence in order. Well, we don't really have a sequence, but we can generate one by using range. The range function actually creates a sequence. It's a generator function that generates integers into system memory. And we put some rules for our numbers that we generate. We said that I want to start from our given input value of num. I want to go towards 0, but not included. And I'm going to go downwards. This is going to be my step-based interval. For each number between all the numbers that I'm trying to go from num to 0, I want to be applying -1 to it. So this is how it goes from high value of num towards 0. Otherwise, range is always increasing because the step value is assumed to be 1 if you don't specify that value. Okay. Range of A and B. Step. If step is not provided, step is assumed as 1. Okay, so we have that, And we're using our multiply then assign special assignment operator so that we're taking answer to whatever was before and then multiplying by I on every time this loop goes. So our I value is going to be first num, then num minus 1, then num minus 2, all the way until it reaches 0, but not including it. Okay, so in this situation, let's try running this code in our visualizer. I'm going to maintain this num to be the same. I'm going to erase all this. And this is going to be our solution 2. Let's visualize our execution. We're going to put value 4 again. All right, it's going to take only 11 steps. We have already created a variable called num, which is 4. Answer 2 is going to be set to initialization value of 1. And we're going to go into our for loop. And I is going to represent 4 because range starts from 4. And then it's going to do answer 2 multiply equal to I, where we're saying I'm going to take whatever was prior and multiply by the current value of I and update it to the newest calculated value. So it becomes 4. Then you're going to notice that I changed to 3, and then we're going to go right to line number 9. We're going to now take this newly generated answer 2 value from our previous loop and multiply by the newest, our new I value. So that's going to give us 12. Then we get to multiply that by 2, 24. We multiply that by 1, and I should be 0, but we never include that last value, so we have actually hit the end of our range sequence. Okay, there's no numbers for i's to be represented, therefore our for loop is over. And then our program's done. I accidentally forgot to copy over the print statement to actually see the print, but as you can see, our variable 2 has updated to 24. Okay, now solution 3 is is very equivalent to the while loop, where we're starting from 1 and going up towards our num. If you ever want to include a value, what I like to do is I'm going to start from this lower value, go up to this high value, and I want it to include that value. Well, what you can do is just add 1 to it, and you will get the same result. You go for 1, and this for loop will end up having j represent num as well, because we ended up including it in our calculation by adding 1 to it. So this range will go up to 1, from 1 to num, and including num because we are going up to num plus 1. Okay, so once again, if we ran all these code, we got the same numbers for both, same results for both, all these 3 solutions. Okay, so what I would say is the following: we had a while loop solution, we had a for loop solution, we had a for loop solution. Maybe I want you to think about, well, which out of the 3 would be the best or the most efficient way to do this problem. That is something that you want to think about for the future. But as always, thank you for watching and stay classy.